Hi everyone, good morning to you all. Welcome back to science class. In the last session, already we are discussed about important concept about the electric generator or AC dynamo and schematic diagram of AC dynamo and working of AC dynamo already we studied. Once I will say shortly. So first electric generator means it's a device used to change the mechanical energy into electrical energy, right? So working armature, the rectangular coil along with slip rings is called the armature. So working, when the armature is made to rotate clockwise direction, when it completes half of the cycle, the current is produced on the limbs. Means first it's moving along a ABCD direction. D is get contact with the B2 or S2. Then current flowing from S2 to B2, B2 to B1 through a external circuit connected by galvanometer. So the galvanometer already shows the deflection. During second half of the rotation, the current flowing in the reverse order, that is DCBA, means DCBA. So A is gets connected with the S2 or S1, S1 to B1, B1 to again current flowing through the external circuit called as load or galvanometer and reaches the S1. Okay, so in this way, every half of the rotation, the current is flowing in the reverse order is called as electric generator. Now we are going to study the one more new important concept, that is electric motor or DC dynamo. So what is a electric motor? It is a device used to convert electrical energy into the mechanical energy. Now this is the schematic diagram of what? Electric motor, right? So here first north and south, these are two powerful bar magnet, and here the rectangular coil, that is A, B, C and D. So ABCD is a rectangular coil. Here the axle is connected in between the two copper ends of the coil, right? And the axle got connected with two slip rings like P and Q. X and Y are the brushes. Here especially X and Y are the brushes. P and Q are the split rings. Okay, then here I connected the one battery, that is called as, we have to say, the cell, or sorry, the current or the battery. Now it is a schematic diagram. Now I will start the working of electric motor. First, when the armature is made to rotate in anti-clockwise direction, when the armature is made to rotate in anti-clockwise direction, when it completes half of the cycle, the current is present on this side, means ABCD direction. The current is flowing along a ABCD direction, and D is gets connected with the what? Q, means this is a split ring. Then current flowing through the Q to what? The P. This is first half rotation. Actually we call it is here P and Q, also called as like a halves. Halves means they are off, cut. Okay, like halves means like rings like this, cut rings like this. So this is called as halves. So here the first half rotation, current flowing from ABCD direction, and D is connected with the Q and Q to P. This is first half rotation. Actually during second half of the rotation, the current is flowing in the reverse order, that is a DCBA, and A is gets connected with the P. So here by the action of the commutator. By the action of the commutator, the P is split and gets connected to the Y, and similarly Q also splits and get connected to the X. So again current flowing in the same direction. Then it is called the working. Then it is called as the electric motor. Means for every half of the rotation of the coil, the current is flowing in the same order or in the same direction. Then it is called as electric motor or DC dynamo. Here commutator means it is a device which is used to change the direction of the current. Change the direction of the current. So here P and Q are act like a commutator. They split and changes their position. This is called as the working of the DC motor or DC dynamo. Dear students, one more new concept is domestic electric circuits. So among AC current means alternate current or direct current, which is convenient for our domestic purpose. So how the domestic electric circuits are available and how it works? Mainly the electric current is produced in the or generated in the power station, means main power station. So we have to brought the electric current through the wires to our house or the home. But especially the aluminium wire and also the copper wire is used to bring the or to brought the electric current through the wires to our house. So the such two wires are called the live wire and the neutral wire. Electricity is brought to home by the two wires. They are, one is a live wire and the one more is what? The neutral wire. So actually the live wire is a red insulation. This is the insulated by the red color. So the live wire is very important. This is called as a red insulation wire and it's a considered as the positive. And also it has a potential of 220 volts and with 50 Hz frequency. The frequency is 50 Hz. And about the neutral wire, it is the black insulation and it has a zero potential. We call it as a neutral. Okay, so then it has a neutral potential is neutral in the water, neutral wire. And especially the electric current is easily supplied to our houses, right, through the mainly wires, but especially the live wire and the neutral wire both are connected through the passes through the main circuits and means electrical or electric meter to main fuse. Afterwards it passes through main switch at our houses. But very important concept is what? The circuits. So there are many distribution circuits are there in our home. So especially there are two type of electrical circuits at our houses, that is lighting circuit, one more is the power circuit. What is the lighting circuit and power circuit? Lighting circuit means especially the current, the ability or the capacity of the current is only up to 5 ampere. Only a 5 ampere because day to day we are using many more materials or many more electronic appliances. All the materials require their own capacity of electricity. That is why here the lighting circuit consists of only the current of 5 ampere. The capacity is only up to 5 ampere. So the bulbs, fan, some mobile charger and many appliances works under or within 5 ampere And some electronic appliances are very heavy, means they need more electric current. That is why we are using a circuit called as power circuit, okay, with having a 15 ampere of current. That is why gas geyser, air cooler, air conditioner and many electronic appliances are run with the help of the water power circuit, right? And especially each distribution circuit at our houses having a separate fuse. Each distribution of the circuit, okay, having a separate fuse. If one circuit is fault, its corresponding fuse blows off. Once I will repeat, my dear students, there is a distribution, many distribution circuits are there, but each circuit having a separate fuse. If any one circuit is fault by a overloading or a short circuit, only corresponding fuse only blows off and remaining circuits are unaffected by this effect. That is why the fuse is a very important device to keep safe all the electronic appliances at our houses. Then all electronic appliances are connected in parallel across live and neutral wire. Already in the previous session we have studied about the parallel connection and series connection, but in our domestic supply we have to connect the parallel. So this is called as domestic electric circuits.